very succinctly, the basic function of nervous systems is to enable the body to move so as to succeed at the 4 Fs: feeding, fleeing, fighting, and reproduction. And I think that that does essentially capture the important point. Between the sensory neurons on the sensory periphery and the motor neurons on the other end are what, to a first approximation, we can call the interneurons. And the basic function of interneurons is to bring it about that behavior is informed. Part of what the nervous system needs to do is to have increasingly good predictions about what's going to happen in the world. And to the degree, other things being equal, that is motor equipment and so forth, to the degree that an animal has better and better predictions about where food is, who constitutes a good mate, what's wrong with this, will a wasp sting, to that degree, its survival is promoted. Now, much has been asked, especially in the morning session, about nature versus nurture, and do we have a gene for sociability, do we da-da-da. And several people that I chatted with over the break rather mourned the fact that people are still, shall I say, burdened with the idea that there is a fundamental distinction between nature and nurture. So let me just make a couple of obvious points that I'm sure most people here will be familiar with. One of the great things that I think we have learned over the past couple of decades is the distinction as described in the 1970s and 80s was really deeply misconceived. I think it was Sidney Brenner who once said to me something like this: well, look, suppose that Mother Nature got to a point where she said, well, look, what should I do now? Should I put into the genome, synapse by synapse and neuron by neuron, how to make a brain? Well, that would be really very difficult. Or should I, as Mother Nature, and wanting to get things done quickly, should I do the following? Should I rely on the fact that there are many regularities that obtain that the genes can take advantage of? So regularities in, for example, chemical milieu of the conceptus and the fetus, or regularities that exist in the post-birth situation, so that the genes can count on the existence of those regularities to turn on other genes, which turn on other genes, and then we get gene expression in this wonderful, intricate regulatory cascade. So it means really that Mother Nature doesn't have to build it all in, but in a certain sense it's built in, by which I mean that there is this dependency on the environment being in a certain way, and if the environment isn't that way, then something else will happen. And I think that gives us a completely different picture of nature and nurture, and it really does mean that everything is much more intertwined than we used to think when we talked about genes for this and that behavior. It came as a surprise to me, and probably to many other people, to be told that at least in mammals, there are no genes for neurons. I thought, well, how could you know that you're supposed to be a Purkinje cell or a stellite cell or a basket cell unless there were genes for those? But at least there should be genes for neurons. It turns out not so. It turns out that what there are, of course, are genes for precursor cells, which, given a particular chemical milieu, will become a Purkinje cell or will become a stellate cell and so forth. And once you see that, it gives you a completely different sense of how to use the word hardwired, how to use the word predisposed or determined, and so forth. And I think that's all I really want to say about that. But given that Mother Nature has decided to build cascades of regulatory genes and to take advantage of regularities in the epigenetic milieu, it turns out that learning is really a very cheap way to improve both motor control and predictive capacities. You can rely on the existence of certain regularities in nature to alter the neurons, which alter the gene expression, which alter the neurons even more. And so learning is a very, very deep and very, in a way, terribly clever way to manage to increase your predictive capacities. And much of what we call cognition, and this I think really has come to the fore as a result of work in psychology as well as neuroscience, much of what we call cognition is really skill. I think we went into the early stages of cognitive science using language as a model for knowledge in general. And we thought of knowledge as being essentially propositional. But mostly it isn't like that. Mostly it's a skill. Spatial skills, skills for navigating the causal world, to understand the causal structure of that part of the world that's relevant to my survival. I don't think I need to say anything very much about this, except I suppose we are amongst a small minority of Americans who do think, or a small minority of humans, who do think that mental phenomena are nothing other than phenomena of the physical brain. There is no non-physical soul that does the thinking and the feeling and so forth. It's an illusion of the brain to think that we do. And it's a very powerful and perhaps a very useful illusion. And the self, both the sense of self and the self-representation of the body, the self-representation of one as having a past and as having a future, the self-representation that's involved as animals conceive of goals and plans and carry them out, they are all, one and all, just constructs of the brain. I'm not really going to say very much about consciousness, except that although I like the take on it that Christoph and Francis have, for some reason, I guess I'm just kind of a stubborn person. I just kind of look at it in a slightly different way. Okay, am I pressing the button? Yes, I'm pressing the button, but there we go. And this came up earlier this morning, and I think Sydney and I were at least in some degree of agreement. I tend to think that the problem of consciousness is really analogous to the problem that people faced at the turn of the century about what is life. And as you know, of course, some people thought that the answer, well, what's the difference between a dead thing and a live thing, that the answer could only be élan vital, that there is some sort of vital spirit. And perhaps some people looked for the vital correlates, you might say, of livingness. And I don't think the vital correlates of livingness strategy, with all due respect, I don't think that was the strategy that taught us about what life is. It turned out it came from a huge amount of work from cell biology, understanding the nature of membranes, of ATP, of energy use. It came out of understanding molecular biology and how proteins get built and so on and so forth. And it's very interesting that it wasn't that people finally said, you know, well, we now have the answer to what life is.